Hi everyone and welcome to lesson 5 of computer systems. So as you can see, we finished the first topic of data representation. That ended with the vector and bitmap graphic lesson for lesson 4. So the second topic we're going to look at in computer systems is all about the computer structure. So we'll have a look at the three parts of the processor: memory locations with unique addresses, the data and address buses, and finally high-level language translation. So for this lesson, we're going to have a look just simply at the three parts of the processor. We'll learn about them and get to understand what they do. So here's just a quick overview of the computer structure. So if you think of computing in S2, if you were there, we had a really in-depth look at inside the PC, and this is kind of just the advanced level. Okay, so we're going to look really closely at all of the aspects and all of the elements inside a PC. But for this lesson, we're going to focus on the processor that you see here. Okay, so this is our processor, and we're going to look at registers, control unit, and ALU. I'll explain what each part is and what their function is. So the processor consists of three parts, and the first one we're going to look at is the control unit. So this controls the timing of operations within the processor, and it fetches, decodes, and executes the instructions. So basically, the control unit just controls at what pace and the time the operations and instructions come to the computer, okay? And when we talk about fetch, decode, and execute, basically that just means that the control unit is responsible for getting the instructions first of all, then decoding, okay, so just breaking it down, seeing what the instruction is, and then finally executing, okay, or running the instruction. So that's what the control unit does. It just is important to remember that the control unit is responsible for the timing of instructions and operations within the processor. Next part we're going to look at is the ALU, and that stands for arithmetic and logic unit. Okay, so this performs all calculations like adding, subtracting, multiplying, etc. And it's involved in comparisons and decision making. Okay, so I know I haven't done a lot of practical programming yet, but if we think of conditional if statements, okay, so when we're programming, we can say to the program, we can write it in such a way that we throw loads of data at it, and it has to make a decision based on the either user input or something that comes across inside the program. So that's what an if statement is, basically just if the value is equal to x, do this, run this instruction, otherwise do another instruction. So the ALU is responsible for carrying that out, okay? So any decision making, comparisons of values, or simple calculations. The way I like to remember the ALU and its responsibility is I take the arithmetic part of the title and just think of maths, okay? So in maths, obviously, we do loads of calculations. So just think if you ever come across something where you have to add or subtract or make any decisions to do with data, that's all going to be done in the ALU part of the processor. The third part of the processor that we're going to look at then is what we know as registers. And these are temporary storage locations within the processor itself. They can store data, addresses, and instructions during processing. So registers, because they are temporary storage, obviously small pieces of data can be stored there at any time. Addresses I'm going to look at later on in this lesson, but then also it can store instructions. So just think of the control flow, the control unit. If there's loads of instructions going to the processor at one time, what it'll do is transfer some of those instructions to the registers just until it gets a chance to then finally look over them and decide what needs to be done with them. So registers are all about temporary locations for storage. So if we have a look at an example of how the processor would actually work in action, okay, we're going to look at a software program that say we just created from scratch, and then we'll decide based on the 4 scenarios below what part of the processor would be responsible for carrying out each task. So in this example, a program is designed which will take in the names and scores of pupils in a class who have just sat their web design and development assessment. The test is out of 3 and the pass mark for an A is 37. So if we have a look at number 1, which part of the processor will make sure that the instructions are executed in order. Okay, so you should already be thinking it's only one of the three parts of the processor, so either control unit, ALU, or registers. So which part of the processor will make sure that the instructions are executed in order? That's going to be the control unit, okay, because as we've said, the control unit is responsible for making sure that all of the instructions come in at a certain time, and it fetches, decodes, and executes them. Okay, so there's some keywords in these scenarios as well. Executed would always then mean the control unit. Number 2, which part of the processor would temporarily store the A pass value of 37? Temporarily store the A pass value of 37. That's going to be the registers, because they're small temporary storage in the processor. Number 3 then, which part of the processor would compare a pupil's score to 37 to see if they have achieved an A? So just break this scenario down and see what it's actually trying to do. It's going to compare a pupil's score to 37 to see if they've achieved an A. So that's almost like a calculation or decision making. Therefore, it's going to be the ALU part of the processor that's responsible for that. And finally, which part of the processor would add up all of the scores and then divide by the number of pupils to find out the class average? Well, that's just going to be a big sum, basically, that they're trying to do. So therefore, it's the ALU, the arithmetic logic unit. Okay, so hopefully that was straightforward enough, being able to read those scenarios and deciding which one of the three parts of the processor that is responsible for each. Okay, you'll have to make use of some of that in the task sheet attached to this lesson as well. Moving on then to memory locations. So every storage location in memory has its own unique address. Okay. So that each location's contents can be referred to individually. If you have a 64-bit computer, the amount of data that you can store in each storage location is restricted to 64 bits. So that's what 64-bit computers mean. It's that the storage locations are restricted to however many bits there are. So we know that 64 bits is 8 bytes because there's 8 bits in 1 byte. So all data and instructions need to be broken up to fit into each memory location, and it's vital that the address of each of these locations is available to locate every piece of data. Remember I said that in the processor, the registers temporarily store addresses. So if the processor's working overtime, these little unique memory addresses are going to be stored in the register part of the processor. A modern computer may have a main memory, or a RAM, random access memory, of 8 gigabytes, and each storage location is only bytes. Okay, so how many storage locations will there be? This is how we then calculate it. So we have 8 bytes in each storage location, which is going to give us, if we have an 8 gigabyte RAM, we're then going to have 1,073,741,824 storage locations. So that's quite a lot for the processor to handle if you think of all of the information and data that's coming through a processor at any given time. We're now going to look at what we call buses. Okay, so there's 2 types that we need to look at, and you can see here the highlighted one, data bus, is what we're going to look at first, and then we also have address bus up here. So a data bus is a collection of wires, so they're actual tangible physical wires that you can touch, which connect the processor and main memory. It is bidirectional, which means that data can travel in both directions on these wires. So bi just means 2, so bidirectional. Now data, which could be instructions going to the processor to be executed, or data may be the result of a calculation going to main memory for storing and later output. In a 64-bit computer, there will be 64 wires in the data bus. Therefore, all data travels in chunks of 8 bytes, and this is what's known as the word size. If we then have a look at address buses, so the address bus is a collection of wires which connects the processor to the main memory. The address bus only ever carries the unique address where data is to be found or stored in main memory, so it is unidirectional. and uni just means that it goes one way, as this address information will only ever travel from the processor to main memory where the address will be used. And that's everything that you need to know for this week's lesson. Okay, I've also put all of that theory onto the task sheet, but everything that you need to know is in this video and on the task sheet for answering the questions. Okay, also if you have any questions or concerns, just add a comment to show my homework and I'll help you as soon as I can. Okay, but good luck.